Good morning, everyone. Today we are going to see VPCs. VPCs are the networking part of AWS, that is a networking service offered by AWS. Earlier we saw S3, EFS, EBS, and Glacier and Storage Gateway all form the storage services, and we saw how to use them along with EC2s by launching instances, taking backup of the instance by snapshots or images, and launching them into auto-scaling cluster. But so far we have used the default network capabilities that was offered to us by AWS. In a production environment, you will be asked to customize your network layer so that your existing infrastructure can interact with the AWS infrastructure. For that, you need to learn how to create your own network infrastructure in AWS and also how to customize it or extend it based on the features available here. So VPCs is a service that helps you to do exactly those kind of activities. So let us go ahead and look in detail what are all the components of VPCs and how to create our own custom VPC. So basically today what you're going to see is a general introduction of VPCs and create a custom VPC and what are all the extensible capabilities, like for example how to connect your AWS VPC to another AWS VPC or your on-premise data center to your cloud. Those kind of scenarios we will see, and there are at least 2 to 3 demos. Today I will try to show 2 demos, and if possible we will see the third one as well, and each one builds on the other one. So I would require all of your attention to be here, because this is one of the foundation blocks of AWS, and without understanding VPCs it would be very difficult when you are trying to make a complicated architecture or complex architecture. Instead of saying complex architecture, I can say when you are dealing with a lot of services, then understanding of VPCs becomes very important. The reason is, if you want an isolation of resources between, if you want isolation of 2 resources in AWS, then VPCs is the tool that you will first use. So a good understanding of VPCs will go a very long distance in knowing AWS. So there are multiple components in an AWS networking service. VPC is one of them. After VPCs, we will look at Elastic Load Balancer, Route 53, and Direct Connect. So let us go ahead and see what are all the basic components that an VPC is made of. Typically, a VPC has most of these components working together. That is, you need an internet access through that is provided through an internet gateway, and if you want access to your private data center or your corporate data center, then you will use an VPN gateway. Then if you want a load balancing capabilities, you can use an ELB. This is quite an optional if you want to have multiple instances and you want to front end them with a load balancer. A routing table is almost always mandatory. When you create an VPC, Amazon provides you a custom routing table and you can extend it, customize it, just like in any Linux or Windows environment. Likewise, subnets and security groups are 2 levels of layering that you can have in VPC. We will look at each of these features in the coming session. Let us just go ahead and start with what is a VPC first of all. So this you can say as an official definition that Amazon provides you. What it means is you have a group of resources and each of them logically isolated, not physically but logically isolated, and these resources have a common security and interconnections. What it means that is you can have 2 or 3 EC2 instances working together in a particular logical group, and all the security, that is ports open, ports blocked, who can access, all those security are shared by those group of instances. You can call them your web layer VPC or your data layer VPC, or even bigger saying my finance department's VPC. So it is fully customizable and logically isolated from other customers and share some common phenomenon like security and interconnections. So when we are talking about VPCs, you should know that your VPC can reside only in one region. But when it resides in one region, say for example Mumbai region, within that region it can spread across your entire availability zone or only one availability zone. It can be only in EU West 1A, or it can spread across, as you have seen in this diagram, it can spread across all three availability zones also. But each subnet, that is, we look at the subnets. Subnets is nothing but a small category of IPs within the VPC. But one more thing I wanted to tell you, you need to have a very good understanding of CADRs. That is the next topic that we are going to talk about. If you are not having a good understanding, I would recommend you to read up on how to create your own CADR range and how to split them up basically. I'll show you a working example, but that will be demo purposes only. In production level, if you want to create a VPC, if you want to create a subnet, you need to have an in-depth understanding of IP addresses and what CADR ranges mean. So each and every subnet in an VPC is nothing but a group of IP addresses, probably 256 IP addresses or 10 IP addresses. You can split it in any way. So you split them into one availability zone each, and you will get something like a subnet for each availability zone. It could be private subnet, it could be public subnet, it could be a subnet usually follows an application structure, you can say. So all the web servers, I will put it in my public subnet because it is going to access my internet. And all the database layers, I am going to put it in my private subnet because I am going to protect my databases from direct internet access. So if you look at it in detail a little bit, it looks like this. You will have your VPC range something like 172.30.10. This is the default that Amazon provides you. You can customize your VPC to any number, either in 172 series or in a 10 series. These are the two IP series available for private routing. You might be knowing that already in your career. So you have a maximum of 64 IP address, that is /16. If you do /16, you will get 64 IP addresses, and if you have a /24, you will get a minimum of 251 IP addresses. Amazon says these are the ranges that you can create a VPCs from, anything in between from 16 to 24, 17, 18, 21, 22, anything you can use. And always keep in mind that out of this, let us say you are using a /24 CIDR, Amazon reserves 5 IP addresses for its own purposes. That is why you don't see 255 here. I'm sorry, 4 IP addresses. That is why you see 251 here. The 4 IP addresses are, as you already know, one will be for broadcast, the another one will be for gateways, and another 2 are reserved for future use by Amazon. So you are not going to get all your 255 IP addresses, you are going to get only 251. This question gets asked sometimes, saying why you are not getting all your IP addresses when I define my range as /24 or /25. So this is how your subnet looks. Let us say this is your whole VPC, that is 172.16 range, and within this availability zone I have created 2 subnets. One is public subnet, another one is a private subnet. And likewise I have created public and private subnet in each of those availability zones. So I will put my web servers here, here and here so that they all work in a public subnet, and I can create a security group to allow port 80 traffic. Whereas when it comes to private subnet, I will be opening only my database port in this security group. So let us look at the next one, how it looks like. Before just jump to security group and come back to another one. So just the same thing I was talking about. A security group acts as a virtual firewall, that is a stateful firewall that controls traffic to one or more instances. That is exactly what it means. The red color line that you see is your web security group that I am creating, and I will say allow port 80 traffic to all the instances residing on this subnets. And I'm going to create another security group here, which is going to say DB security group. You can create any name for you, but it is always prudent to give a user-friendly name so you remember what is going on inside it. So this is how you create a security group and allow ports into it. So the next one gives you a more pictorial representation of how a security group looks like in real life. Say for example, I am saying port 80 and port 43 is allowed. So in my firewall, I will have a rule for that so that my web tier will have direct access through port 80 and port 43. Whereas when it comes to administering these servers, I will be enabling RDP here, either port 22 for SSH or 3389 for Windows servers, and I will be creating a bastion host. Some people might be familiar with the concept of jump server or terminal server or bastion host. In other words, this is the server through which you can administer all the three servers, that is running application, web and database. So I will be creating one more layer for this for management, and I also can create a synchronized with on-premise database, a secure port through a VPN tunnel or through direct connect from AWS. So that will not have any port because it is an IPsec connection, and it will be passed allowed in my security groups. And if any other port is trying to connect my instances, then it will be blocked by my Amazon security group. So that is how security group plays an important role in VPCs. And always remember, in security group, by default, everything is denied. You don't get any outside or internet access. If you want internet access, you need to enable it. If you want port 22 access, you need to enable it. If you remember, a few days back, I was trying to start a web server and I was having difficulty connecting to it. And one smart gentleman told me port 80 might be blocked in your security group. So that is exactly how the real life situation is. When you create a custom VPC, your ports are by default blocked. You need to open them to get it working. And another thing to remember about security groups is security groups are stateful. What it means is you need to say only allow my incoming connection. So your return connection will also be automatically approved. Just give me one moment. I'm sorry for that. What I was saying was security groups are stateful applications or stateful firewalls. In other words, they remember what is the incoming IP address, what is the incoming port, and they can return the traffic in the same way. You don't have to create inbound rules separately and outbound rules separately. Whereas there is another concept that we will see down the line. It is called network ACLs, which are not stateful. That means that you need to create separate rules for your inbound access and your outbound access. I talked about giving access to your VPCs through to the internet. So for that in Amazon, what you need to do is you need to create an internet gateway and attach it to your VPC. So what it looks like is this: you will have a separate tab and you create an internet gateway, and you go ahead and create a routing table saying all the internet traffic destined for this IP address, that is anything not matching any other rule is destined for internet. That means send it to my internet gateway. Your internet gateway ID will look like something like this. When in the previous tab, when you created your internet gateway, you will get it like this, and you will go and attach it and say create a routing table which says this one, and then give it to the gateway. I will show you how to do that. So the logical process while creating VPC is you decide on a AIDR range that you want to create, and then you create your subnets, and then you create your internet gateway, and then you attach your routing tables. So as I said, your VPC has a default routing table, and but you can assign different routes. I'm not going to spend much time here because most of you should be familiar with what is a routing table, and the same concept applies here as well. When you see a local, that means that is all the traffic stays within your VPC alone, and this is the default route that you get when you create a VPC. So we looked at security groups. So in other words, a web security group is an example of a web security group. What I will do is I will create an HTTP rule with port 80 range and say all over the internet it is accessible. When it comes to my DB security group, what I will say is, I will create a custom rule assuming that my DB is running on a different port, that is 2345. If you are running an Oracle port 1521 3306 for MySQL, it depends upon your database and you enable the port. But if you remember source, in the previous one I have given source, that is incoming traffic, as internet. But when I go to my database layer, next slide, I see I am giving a source as a security group ID. What it means is only my web servers can reach my security group. That is, traffic from my web servers can only reach my database servers. The world, it is not open to the entire world, and the entire world cannot access my database directly. So this way I'm increasing the security of my database layer by not exposing it to the internet. So these are all some of the security concepts built into your AWS networks. You can have firewalls by security groups by blocking incoming ports, and you also block your incoming traffic by based on instances also. That is two different concepts. So I told you that there are another stateless firewalls available in VPCs. They are called network access list. When security groups are applied to the entire VPC, comparing with NACL is NACL will apply only to a subnet. You can control each and every subnet's inbound and outbound rules through your NACL list. By default, you will see these two rules that you see in the bottom. What it means is allow all traffic. By default, in your NACL, all traffic is allowed. But remember, at the security group level, we are blocking everything. So at the subnet level, I am allowing everything. So what it means is, on a very major level, I am closing my gates, and in the small rooms inside my house, I have kept my doors open. That is what it means in a very English way of saying it. But technically, so security groups apply at VPC level, NACLs apply at a subnet level. That is what you should remember here. So the rules are going to be applied on a numerical basis. Let us say 100 is your rule, which is going to say allow, and 110 is the next rule, which says deny for internet. Then 100 only will take precedence. So the rules are in numerical order, and Amazon recommends you to create a logical way like 100, 110, 120, something like that. Keep on increasing, so you don't have to jump here and there and start creating rules which will conflict each other. So always create rules in increments of 10 or 50 or 100, something that works easy for you. And always remember that the rules are incremental. The smallest rule number will always take precedence over everything else. And you can ask me what this star means then. If traffic comes into AWS VPC and it is not matching any of the rules that you have created, then this rule will be applied. That means that here I am saying 100 and I am saying allow, whereas in star I am saying deny, but still my 100 will take precedence because that is the smallest number here. So these two concepts are also important for creating an appropriate firewall rules based on your subnets. Then you can have DNS options in your VPCs. That means that within your VPC, you can have your own DNS resolution and your DNS name. For example, you will be noticing that Amazon EC2, when I'm creating, I get a big host name, something like ec2.ipaddresses.asiapacific.amazonaws.com, something like that. So that is enabled and that is configured because in my VPC, I have these two options enabled. DNS name resolution, as well as a routable host names. So broadly, this is how your security in your VPC looks like. You have your VPC that is spreading across two availability zones, availability zone A here and availability zone B here, and you have your instances running and you are applying a security group which is at a VPC level. Then you are isolating your networks based on your subnets. Say it is /24/000/24 and 10.0.1/24. You notice the difference. This will give me 255 IP addresses on this range, and this will give me 1.0 to 1.255 IP addresses. There are CIDR expansion tools available. If you just copy paste this IP address in the CIDR expansion tools in the internet, they will tell you what is your starting IP address and what is your ending IP address. For this one, for example, the ending IP address will look like 10.0.0.255, and this one will be 10.0.1.255, and you see the first one listed here. So again, at the subnet level, I will be applying my network ACLs, and again I will be using routing tables to ensure that not everybody can send traffic everywhere, and only my routing table will apply to the security group or my VPCs. So this way you have multiple layers of security built in your VPCs, and it is very important to understand how these concepts work and which one will be the best one to apply when you are creating a production level environment. This is not required for an every day-to-day architecture to how to create a VPC, how to create a security group. But if somebody tells you, I want an environment to be set up, what are my security options, what are the tools that I have in hand, then these are the tools that you need to think of when you're trying to answer that question for your customer. So that is the basics of VPC, if I'm not wrong. Let me just go on to the next one. Okay, this is what we are going to do now. We are going to build our own custom VPC right now as a demo, and I'm going to create a public subnet and a private subnet, and I'm going to create this entire flow right now slowly. I'm going to create a web server, and I'm going to try to connect to the web server. Let us go ahead and do that. Just one moment. So once again, I'm in the VPC dashboard. If anybody is not sure how to go to the VPC dashboard, as usual, you can click on the services at the top and it gives you a search bar there, and you type VPCs and it will take you to the dashboard. So by default, each of your accounts will have one VPC per region and one internet gateway, two subnets, and the subnets will depend upon which region you are in. For example, if you go to Oregon or Virginia, you might see multiple subnets, but this is the default configuration that everybody should see. So the easiest way to start creating a VPC is through the wizard, because it will do a lot of work for you. So what I'm going to do is I'm going to show you how to do once with your wizard and once with using the options manually one by one. So let us go ahead and create a custom VPC through the wizard now. So you have four different options here, that is create a VPC with a public subnet or create a VPC with public and private subnets. So let us go ahead and create one with the public and private subnets now. So it gives you a small architectural diagram that makes you to understand very clearly how your VPC will look like. Say for example, here is your public subnet and here is your private subnet. And what private means is these guys don't have internet access, and if they want internet access, they need to talk to this NAT gateway and then talk to the internet that is here. It could be S3, it could be internet or anything outside your VPC. That is what it means. And public means all the instances can talk to the internet directly through using an internet gateway. So we are going to go ahead and create that. Click on select. So Amazon by default gives me this 10.16. I don't want to use that. I'm going to use a custom one, so I don't use a confusion. I prefer anything after 10. You can use any number here, but you need to know what you're doing here. This is a class C IP address, this is a class B, and this is a class A. I don't want to talk about CIDRs, and I don't want to confuse you guys because IP address learning is a completely altogether different ball game, and I am not spending time and teaching here because it itself is its one own class. It takes about 1 to 2 hours to learn about how IP addresses work and CIDR ranges work. I would strongly recommend, I can ping you a couple of URLs at the end of this class on how this expansion works and what this /24/16 stuff means, if you already didn't know. I'm going to give /23 because that is going to give me 512 IP addresses. See this, it was saying 62, okay, it is changed now. So it should be 512, and Amazon has taken up 5 IP addresses for reservation purposes. So I'm going to leave this IPv6. I'm not going to use IPv6. As you can see, I'm using only IPv4. So leave this option empty. I'm going to create a demo VPC now. And it is asking me what is my public subnet. So I'm going to say 23 will give me half, 24 will give me half of what is here. So out of 512, I will be creating a public subnet which is having 256 IP addresses, and Amazon has taken up 5 for its own purposes. So again, I'm going to say my public is going to be in AZ1A. Very clearly, you see, I am splitting my application into different AZs now. So public sits in 1A now. And I'm going to create a user-friendly name which says public subnet. And here, once again, I'm going to change this one to 81 because that is where my VPC range is from. So again, I'm going to have 256 IP address. So I split my 512 into 256 and 256 into public and private now. I'm going to put all my private in availability zone B. So once again, let us make it user-friendly, small names, easy to remember. So it is asking me, do I want to create a NAT? Let us, as of now, I don't have an elastic IP, I don't have a NAT. You leave it as it is empty. We will create an internet gateway outside if it is not created. So remember, I told you about DNS host names, and it is by default. Clicked on yes. And this hardware tenancy is, remember yesterday we talked about the purchase options. It is asking me whether any instance created in this VPC should it be launched on dedicated instances. I'm going to leave it as default because I'm not running any production level instances right now. So all that it is to create a VPC, let us go ahead and click on create. Before creating, I just want to show you how it looks like on your dashboard. So we will see what is getting created. Just created another tab on Mumbai region only. I'm going to see my dashboard, show you my dashboard. So this is VPC. I'm going to click on this. Has it refreshed? I believe not so. Just waiting. I'm clicking on the VPC link there. So as of now, you will see only one VPC range in my dashboard, and that is also using 172.31 range. So let us go ahead and click on create and finish our configuration and come back to see what happens there. Oh, it is asking me elastic IP. Okay. Okay, great. Let us go to EC2 and create an elastic IP for my NAT. Okay, if I do this, I will be jumping a gun, guys. I don't want to jump a gun. I want to build up slowly. What are the options I have now? Okay, I don't want to confuse you guys. So let me go back little bit, start my VPC again. I'm going to create only a single public subnet because for private subnet, automatically it will create a NAT instance. I don't want to jump the gun and let the tool itself create it for you. I'm just going to show you one by one then in that case. So let us create a public subnet alone for now. This one 23, that will be 512. Okay, great. Demo VPC and 8123. Reference is AC1A and name is public subnet, and leave this as empty. I'm going to click on create now. So it is creating a routing table, it is creating the internet gateway, attaching the internet gateway, and all these activities happens. So it says that it is completed. So I'm going to click OK, and anytime you should see a new one here now. So what has happened is it has went ahead and created a VPC for me, as you can see here, and let me go ahead and click on subnets. You see this 10.81.0, I will be able to see a subnet which is saying the whole of the VPC. I gave the /23 whole of it. And if you want to modify anything, it is not at all possible. If you see here, I don't have a modify subnet at all. It is not like your storage, it is not like your servers. Once a VPC is created and it is for final, you cannot modify your VPCs, you cannot modify your subnets. So that is why I keep on saying understanding your CIDR range is very, very important, because you cannot modify it if you create a small number of servers. Let me put it practically. Let us say that you are creating a VPC which is having a capability of hosting 512 servers or 512 IPs. And after some 1 or 2 years of growth, your customer says that I want to put more servers into that VPC so that all of them can talk to each other. But you have already reached your maximum limit. You cannot add other servers there. So you will be forced to create a new VPC, set up all the rules and configurations, and try to connect both of them. So these are all the additional headaches that you will encounter when your VPC is not having enough IPs which can accommodate the future growth. So always think of that and design your VPCs. Now coming back to our demo, we have created a subnet, and if I will come to routing table. Before that, I'll just go to internet gateways. And you can see the wizard has already created an internet gateway for my demo VPC, and you will see that it is attached to my VPC as well. I will do that without a wizard in the next demo, that is when you are setting up an NAT gateway. So going to routing table, there are two routes here, as you can see. Let me type demo so that will filter and show only my routing tables, that is the custom routing table. So you can see two of them, and only one of them is associated with any subnet. I'm sorry about that. I'm going to select that one which is having a subnet associated. What it means is, if I go to routes, you will see that all the internet traffic is routed to my gateway, and it is associated with my public subnet, that is 10.0.810023. And if I scroll down, is there anything else to show here? A security group by default will be created for me. That is, let me once again type demo here, so it will filter my VPC alone, and you can see there is a default security group. I'm selecting it. So you can see as of now there are inbound rules which says all traffic, all protocol, but it should originate within my security group. That is, whatever is originated within my security group, it will end within my security group. It will not go outside the network, it will not go anywhere. So I want to have port 22 access and port 80 access to show a demo. So what I'm going to do is I'm going to add another rule. I'm going to say SSH port 22 and SSH. I don't know what is my public IP address. I will come in. So I'm going to say allow all the internet to access my server through port 22. Likewise, I'm going to say HTTP, which is port 80, and allow access through the internet so anybody can browse my website. And I'm going to save on that. Remember, I told you security groups are stateful, which means that in outbound I'm not going to create any rule, and by default all my outbound is allowed. If you want to really customize it, and if you understand what you're doing it, go ahead and edit it so the incoming and outgoing will be in matched. Otherwise, leave it as it is. I talked to you about network ACLs. Let us go ahead and see that as well. There will be on, I'm going to filter it based on my tag. So I have one ACL which is available. I'm going to click on that, and you can see my inbound rules now, which says 100, which says allow all traffic. That is by default my network ACL allows all traffic in my VPC. It doesn't block anything. And you also remember network ACLs are stateless. They are also giving you a soft warning here by printing out this message. So that means that you need to create inbound rules and outbound rules. So I clicked on outbound. You will see a similar or allow rule here as well. And if you're very clear of what you're doing, go ahead and create network ACLs based on your subnet. And you need to associate your subnet also so that it will affect those particular subnets only. So as of now, we have broadly created a VPC, and let me show you an image to see if I can show that. Okay, this is what I have broadly done. I have created a public segment. Just think of this is also 23 for now. We have created a VPC and within availability zone 1A, and we have created a public subnet also with 81/0023 here. This diagram is for the next demo that we are going to see. So 23 here, and we also have an internet gateway attached. This is nothing but a VPC router. So just all the traffic from this server goes to my internet like this. So I'm going to start an instance and see whether it is going to work or not. Let me go back to my demo console. So I'm going to EC2 now. I'm going to launch an instance. We talked about all these things, so I'm just going to breeze through this as fast as possible. The important section I will explain choosing my server. Here is the important part. I'm going to wait for the screen to refresh for you guys. So here in my network, I am seeing my demo VPC. So I'm going to choose my demo VPC, and subnets, I have only one, so it has automatically chosen that subnet. And I'm also going to say allocate a public IP address so I can connect to it from the external world. As usual, you can create a role or later also assign a role. I'm going to say install HTTP server. Quite often I see this script failing, but anyway I'm going to try it once again. Okay, that is my simplest script that I'm going to run. I'm going to check storage, nothing there, storage, and then going to create a tag which I'm going to say as public instance 1A. Okay, that is in 1A region. So I'm going to say that I'm going to choose my security group, and I'm going to select a security group where I allowed my port 22 and port 80 access. I'm just going to confirm whether those things are there from internet. Yeah, it is there. Let us go ahead and launch the server. So let me open my terminal. Since you guys are familiar with all these creating the server and launching the terminal, I'm just going to skip ahead and go fast with those things. Wherever it is related to VPC, I will slow down and show you where it matters. So here you can see my public IP address, the private IP address is one from my own subnet. That is, it is not the 172 IP address which we were seeing yesterday. It is from my own VPC that I have created 10.81.1.162. That is Amazon picks one from my own subnet, and you can see this VPC is the same as if I go here. I'm going to go to my VPC console. I'm just going to show you if I'm going to search for my VPC. See, it is coming from the same VPC. So you can see the Amazon EC2 instance is running inside my custom VPC now. So let us go ahead and put this in the browser and see if my HTTP server is already running. If it is spinning for such a long time, there might be some issues. I'm going to connect to my server through PuTTY to see if there is any issues. Okay, it worked. So you can see my custom VP. I have created a custom VPC, and I have created a server, and I have installed a HTTP Apache server there, and I am able to access it through my internet. So that is what we set out to decide in my wizard. Create a public subnet. Now let us go ahead and see how to create a private subnet so that we will know that certain instances cannot access the internet. Let me go ahead and use the architectural diagram to understand what I am talking about. So this is what I want to create a demo and show it to you. That means that we have set up this one now, public subnet, and there is a private subnet as well. I'm going to set it up from fresh using the console now. I'm not going to use the dashboard. I'm going to set everything using the console now, because you need to know how to create your subnets, how to create your security groups, routing tables, and all those things. So I'm going to create the other way around. Before that, I'm going to reuse my IP addresses. So let us go ahead and delete this.
Naveen, quick question.
Yeah, Anand.
Yeah. So what I see is public subnet and private subnet is basically within private subnet, the public facing IPs will be public subnet, and the backend servers will be private subnet. Is it right?
Yeah, yeah. I mean, it's more a logical understanding, Anand. There is no, Amazon doesn't do any additional terms there, because if you remember, the words are, I am typing those words, public and private. So a broad understanding is when somebody says a public subnet or public instance, they will have internet access and they are open to the internet. And whenever I'm saying private subnet or private instance, that means that that instance is not directly accessible from the internet. You need to go through a NAT gateway or a NAT instance, or something is sitting in front of it, then only it can access the internet. And you are also right. People generally put public instances means web servers and private instances means database servers. Does clear your doubt, or I confuse you again?
No, if I have any, I'll just come back.
Okay.
But now it's clear.
Okay, so this is how you delete a VPC. You just go ahead and click on, select the one that you want to delete. I'm going to click on actions and then delete your VPC, so that we can use the same terms that we are familiar with. I'm going to delete everything. So it deletes all these options: subnets, security groups, ACLs, gateways, routing tables, everything associated with the VPC will be deleted. I'm just going to go to my EC2 dashboard and see if it is terminated. Yeah, good, it is terminated. Usually it takes about a minute or so. Okay, great. It is clean, and back to our console. I'm going to start again on create VPC. So this is how you do it through the individual options instead of doing the console. I'm going to use the same words, demo VPC, and CADR block is 10.81.0.0/23. So that gives me 512. Leave it as default. Click on create. So I'm seeing it here. I'm going to go ahead and create my subnets now. I'm going to create two subnets. Let us create the first one now. I'm going to type it demo here, so only what I want is appearing. So the name tag is going to be public subnet, and you see here I'm going to choose this demo VPC, and I'm going to choose 1A for my public. I'm going to give a range of 10.81.0/0/24. That means out of this 512, 256 will be allocated for my public subnet. Just go ahead and click on create. I'm going to create, once this is finished, I'm going to create a private subnet. Okay, we got it created. Let us go ahead and create our private one. I'm going to put all my private subnets into my 1B. Just I'm differentiating so that it is easier for you to follow. 24, okay, create. Next is I'm going to create an internet gateway for our VPC and attach it to our VPC. So these two are created, and you can see the IP CADR ranges 24, and it gives me an available of 256 IP addresses, and you can see my AC zones, that is public is in 1A and private is in 1B. So I'm not going to change anything this as of now. You can just think of it as a shortcut for routing table that is here as a shortcut here. Let us go ahead and use only these options. I'm going to create an internet gateway first. By default, I will have one. This is for the 172 series. Let me type on demo here. So we will not match anything. Okay, nothing is matched. I'm going to go ahead and create one. So internet gateway for demo VPC. Oh, I'm sorry, there was some error. I don't know. Anyway, wow, crazy guys, I got logged out. Let me log in back again. Let me see where I am in. It says internet gateways filter as demo. Let us see whether it is created or not created. Okay, demo VPC is not created. I'm just going to search for it once again so that I can be sure nothing is there. Internet gateway for demo VPC. Okay, you see by default internet gateway is not attached with any VPCs, so it will show it like this. I'm going to click on attach so that my VPC, demo VPC will be attached here. And remember about the DNS host names that I talked about, I forgot to enable it, so I'm just going to go ahead and enable that. So this is my demo VPC. Let me select that, go to actions. I'm going to say edit DNS host names and choose yes here so that I will get the big dirty host name that Amazon gives me. So that is also enabled. I'm going to add a routing table so that internet traffic will flow to my gateway now. Once again, let us type demo. So this is my default routing table, and you can see as of now no subnets are explicitly associated. So what we can do is I'm going to leave the main, it says yes, that means that Amazon has created this routing table when I created the VPC. I'm going to leave this alone. I'm going to create a routing table and allocate it to my VPC. So demo VPC RTB, that is the term I usually use, routing table RTB. I'm going to choose the demo VPC and click on create. And as you can see, there are no subnets associated in any of those subnet, any of those routing tables. Both of them are saying 0. Let us first of all go ahead and add a routing for internet traffic. You go ahead, click on routes, click on edit, just like I showed you security groups. So internet traffic is coming from, this is the common for internet traffic, and by default it will show me my internet gateway here. And leave as it is the rest of it, click on save. So I'm going to associate it only with my public subnet. As of now, 2 subnets are there, but you say this message says you do not have any subnet associations, and you can see in the top also that this subnet association, this value is 0. So since there is an internet gateway, I'm going to attach only my public subnet. So let us go ahead and do that. So select only the public subnet and click on save, and you will see the number at the top changing in a short while. So you can see this is associated now. Okay, great. And I'm going to add, because I deleted the VPC, remember, along with that the security group also disappeared. I'm going to enable port 80 and port 22 here in my security group for my demo VPC. Somehow disappeared. Okay. Okay, click on save. So we are all set to start an instance in our demo VPC once again. I am not yet starting anything in my private as of now. Let me show you one by one. I'm going to start one more instance now. The previous time I showed it with the wizard, and now we have done everything with the console. I think this one also logged out. Let me log in. Okay, as of now, as you can see in Mumbai region, I have nothing running. Let us go ahead and launch a public instance. Once again, I am choosing my demo VPC, and out of if you okay, let it refresh for you guys. So I have chosen demo VPC here, and it gives me a choice of two subnets now, because we have two subnets. One is public, one is private. I'm going to create one on the public one now, and I'm going to assign a public IP address, so I want to access it. So once again, let us create our web server so we know that we can access it from the internet directly. I probably need to write this code somewhere so I can reuse it. That is what we are going to see in a short while. I'm creating a public subnet now, and when I put it in the private, I will need a NAT gateway to access that. HTML. Is that spelling is correct? www. Okay, that's all great. Nothing here. Okay, I'm sorry. That should be public. Okay, both the ports are open. Launch. So as usual, if you come down to the bottom, you will find those information that we just now provided to Amazon. The new VPC ID is different from the one this server had. So, and again, once again, my private IP address is also different from what I earlier had. It is still on pending state. Just give it a moment so that the web server can start and be up and running. Okay, you'll have to give it a minute then. So what else is there to show here? After this is completed, we will go ahead and start an instance in our private subnet. Okay, so my web server has started, so we can see that my web server is delivering the small web page that we just created. Let us go ahead and start an instance in our private subnet. So this is in 1A, because if you remember, 1A is for our public. So just minimizing this a little bit more. I will just add a word here, demo, so I can filter the instances by name, demo. Okay, strange. What I can do is instance state is there. There's one more keyword is there. I'm going to say running. So only my running instances will show now. Okay. Launch instance. Okay, here you see I'm going to choose this option private subnet 1B, and I'm carefully not going to assign any public IP address here so that it is not reachable from the internet, and it is going to have only a 10.81.1 dot something. So let us leave it as it is. I'm not going to start any web server here, so I'm going to leave everything empty here. I'm just going to click on add storage. Again, storage is nothing, so go ahead and create a name tag, which is private instance demo. Configure security group. Again, I'm going to use the security group I already created. Although it says allow internet traffic from port 22, I will not be able to access this server. Let us show that right now. Go ahead and launch it. I'm going to duplicate my EC2 console. So you have two tabs. Let me remove this filter and apply the state filter. Instance state, and okay, let it go to running. Okay, great. So we have two instances, one public and one private, and I have selected my private, and you will see it is already in running state, but I don't have any public DNS or anything. I have only a private IP address 10.81.1.50. I'm just going to select my okay, wait a second, instance state running. Okay, in this tab. So in this tab we have public, and in this tab we have private. So in public you can see I have the full DNS host name, which is internet routable, and I also have a public IP address through which I can connect to the server. So what I'm going to do is I'm going to connect to this server through PuTTY now. So 1A, I'm going to use this one, server 01. Let me edit this session and put in the host name that we just copied. Let us just rename it for this purpose. Public instance. I'm going to check my security key and say the Mumbai key is used. Okay, I'm going to click OK, and I'm going to double click to connect. And you can see already it is working, and I'm able to connect to the server. So what I'm going to do now is I'm going to try and connect to the private instance now. Edit. Let me go back to my console, copy the IP address. Do you think I should be able to connect, guys? Anybody? You can type your answers, you can speak out. I would love to hear. For 1 hour I am talking.
You need to enable mapping like that.
Right. So I'm going to click on this one. You see public instances here, private instances here, and the usual flickering of my cursor is not happening. That means that it is not going to connect in any time. So do you think from public I should be able to connect to this private server? Do you think that will work?
Yeah, it will work because it has private.
And why do you think it will work, Mr. Anand? I mean, there's no right or wrong answers.
Actually, no, it's actually in the LAN, right? So the same subnet, you should be able to connect.
No, it is not in the same subnet. If you remember, both of them are different subnets. One is in public, another one is in different. Both are IP ranges are also different. See, this guy is in 10.81.150.
Oh yeah, I got it.
and this one is in 10.81.19. The reason is
I think port should be open between these two incoming.
You should have routing actually. If routing is there, you can connect.
exactly, guys, you got it right. So I'm just going to go to my routing table and I'm going to show you why it will work. Because if you see any route, you will see the first route is the whole VPC and it says local. That means all the instances, all the resources within my VPC will connect or talk to each other, and the default route is always there. So this is the reason any resource within this VPC, you see this, it is /24, not 23, I'm sorry. That means that the whole of the VPC is covered by this route, and any traffic originated within the VPC will be destined for the VPC only. So everybody, irrespective of what subnet you are using, this route will take care of that. So what I'm going to do is, from my public, I'm going to connect to my private now. So I'm going to copy my SSH key. So for that, I'm just going to pause the screen until I finish copying my SSH key. There's no magic happening here, just I'm copying my SSH key so that we can connect to our private instance. Okay, I need to change the key tomorrow probably because I made the mistake of recording everything. So I could have rather shown you itself. I probably will have to edit it out or probably change the key tomorrow. Anyway guys, I have created a private key, I've copied the private key to the server and I've changed the permissions. So what I'm going to do is, I'm going to try and connect to our hiding fellow there. EC2-user at, I'm going to copy the private IP address. So you can see I'm already getting a prompt, and you see this was the source server and this is where I have logged in. You can see the difference in the IP address. I have logged into 10.81.1.50. So I was able to access this server. So let me just ping the internet now and see whether it is having internet access. Usually if I am pinging internet based server, I will be getting a response of ping response, as we might have been familiar with. Now nothing is happening. Let me just connect to the public instance once again so we can show how a ping response looks like in Linux. This is not going to work anytime, so I'm going to close this. So this is my public server, and pinging Google's DNS server will give me an infinite response. So my public instance is constantly pinging, whereas my private instance is not pinging. That means it doesn't have internet access. So let us go ahead and give internet access to the server. And how do I do that is by creating a NAT gateway. I'm just going to scroll down a little bit to this screen. So you see I have a big VPC here, and then let us say I have the top one is my public internet, and it has an internet gateway and has route to the internet, and it gets connected to the external world, whereas the bottom one running my database servers has only my internet VPC router, but it doesn't have a gateway. So how do I do that is, when I move on to the next slide, I'm going to create a NAT gateway and assign a public IP address to the NAT and route all traffic. This is what I'm going to do. I'm going to create a NAT gateway and route all internet-based traffic from this private guy to this NAT, and this NAT will in turn send my traffic to the internet. NAT is nothing but a network address translation. You can Google about NAT more if you are not already familiar. It just acts as a front end for all your private servers. I'm going to go to my VPC console and create a NAT gateway now. And I will do that in my public instance, public subnet. On your VPC, on the left hand side, you will see NAT gateways. And as of now, as you can see, there is no NAT instances running. I'm just going to type demo so that we will see only one of ours. And also I want to give a small tidbit. NAT instances are chargeable, so don't keep it running for a very long time if you're going to test it, if you're going to run some demos. So be careful about how long you're going to run a NAT instance. NAT gateways. So it gives me all the IP address options that we have. NAT, since it needs to connect to the internet, I'm going to put it in a public subnet. And it is asking me associate an elastic IP address because it should be publicly accessible. But as of now, I don't have any elastic IPs, so I'm going to go ahead and click on create, and automatically a new IP gets created and it gets allocated also. If I click on this, it will show in the drop down as well. So 35.154 is my NAT IP address. So it is created, and I'm going to click on create NAT gateway. So that's it. So now we have done our NAT gateway, then we need to add a route in our private subnet, so all the traffic will be routed there. So instead of doing the click on, this keyword, it is still pending, it needs to become an available state, then only we will be ready to use that. So let me delete this one. It takes a while. Meanwhile, let us go ahead and create our routes for internet access. So this route, let me go ahead and expand this. I'm going to say this route is for public, right? Okay. I'm going to just rename it as public RTP for demo VPC. I'm just changing the tag now. So I have associated my public subnet, as you can notice here. So I'm going to create one more route table, and I'm going to say this is my route table for private subnets. I'm going to leave this as demo VPC. I'm going to click on create. Okay, so we have two routes for demo. Three actually. The main one, leave it. I never touch the main one. I always customize my routes and create one for each of my configurations. So we have one for public, and the public subnet is associated here, and we have one for private and no subnets associated. So let us go ahead and create a route for internet traffic. I'm going to click on edit, add another route. Internet traffic is always this IP address, and I'm going to choose my NAT gateway here instead of my gateway, that is internet gateway. So NAT is chosen here, and I'm going to click on save. I'm going to subnets and make sure my private subnet is associated with this routing table, which is private. This one is private, and as of now it's associated or currently in main. So I'm just going to move it to my custom route table. So in short, we have one for public and one for private. Let me go back to my console and see what is happening. You can see all of a sudden I am getting a ping response from Google. Until if I do Control C, I will see a lot of dropped traffics. So in other words, I have broken out of 356 packets, only 18 is received, and that is 94% loss. In other words, I have enabled internet traffic for the server, and I'm getting a ping response as soon as my routing got fixed. Did anybody did not follow what was happening? Again, silence. Come on guys, say something.
Yeah, Naveen.